All right, folks, I think I'm going to get started. See if we can get this projecting. It's good. Great. So thanks, everyone, for coming to the last session of the first day of Build. I know it's been a long day after a pretty epic keynote this morning, but I hope all you guys are having fun. And I know some of you are probably getting hungry, especially if you're from the East Coast or from anywhere else other than nearby. You're probably hungry. So thank you for coming. My name is Sean Henry. I'm a program manager on the Windows Developer Platform team on the Windows Application Model team. And I'm here today to talk to you about multitasking and background processing on Windows Phone. So first of all, what the heck am I actually talking about? So multitasking and background processing are kind of overloaded terms, especially on mobile devices. And in this particular case, in this session, what I'm talking about is anytime your application is running code when it's not in the foreground. So I'm going to give you a bunch of sessions, a bunch of demos, and I'm going to show you a bunch of new features we've added in Windows Phone 8.1 that allow you to execute code in new ways while you're in the background. And of course, the reason you want to do this is to get users back into your app so they can interact with your brand, and they can view your ads, and they can just love your app and give it great reviews and share it with people. So this is all about ways of responding to the environment and then getting people back into your app. So first of all, I'm just going to start with a bit of history. First of all, quick survey. How many of you have developed a Windows Phone application before? Cool. So a lot of Windows Phone. How about Windows Modern, like Windows RT, Windows YAML, that kind of stuff? Awesome. So you guys pretty familiar with most of the stuff between Windows Phone and Windows. So I got some great news for all of you. But first, quick history lesson. I'm going to come from Windows Phone here because this session's, a lot of these things are kind of what's new in Windows Phone 8.1. So if you've developed apps, obviously, if you've developed apps for Windows Phone from way back, you're familiar that Windows Phone 7, we shipped really without a multitasking model. And then we started adding scenarios with each new release. So we started off with a number of mechanisms to show live tiles and toasts from the cloud, either via push notification or scheduled, so you can provide a schedule where you can retrieve toasts and notifications. We also had what we kind of loosely defined as OS brokered tasks. These are cases where you tell the OS you want to do something, and then it continues to do that in the background. So a good example is like the background transfer service that we had, which allows you to upload and download files that your application chooses while it's not in the foreground. And then finally, more generic background tasks and agents. And so for this particular session, I'm going to talk mainly about number 3 and 4 here. Number 1 and 2 are actually really important as well. And in fact, if you can use them, you should, because they're very good on battery. It doesn't have much of an impact on battery when you actually use live tiles and toasts via push or schedule, because there's very little code running on the system, and we can batch them up and so on. But I'm not going to talk about those here. There's actually a great session that Thomas and Jorge are giving right over there right now on push notifications and doing that kind of stuff with WNS. So if you're interested in that, definitely check out that session online. If you're really, really interested, the door's still open, and you can get out of here. But please stay. I've got some great stuff for number 3 and number 4. So if you've done this kind of stuff on Windows Phone 8 before, you're familiar with the scheduled task as kind of the go-to background execution unit on Windows Phone. The periodic task, which it would fire about every 30 minutes for about 25 seconds, so a very limited amount of time that it could run, not much control over when it would run. And the resource-intensive task, which is a task that would fire when your device was plugged in and charging it on Wi-Fi. And run for a little bit longer so that you could download data, you could sync data if you wanted to do that. We also had to mention the background transfer service, allowing you to upload and download data while you're not in the foreground. Background location tracking. This is, for fitness applications, turn-by-turn navigation applications that wanted to continue to sort of track your location, log your location in the background while you were doing something. And then finally, we had some sort of scenario-specific agents for voice over IP and audio. So if you're like internet radio or someone like Skype, you could use these very specific agents for those scenarios as well. And those were tied into a lot of the UI in the system. The play and pause controls on the top, as well as integrating with the cell phone calls, the call service on the phone. So that's kind of what we had on Windows Phone 8. the big question now is, where are we going? So I hope you got the impression from the sessions you've been to today and from the keynote is that the big word is, convergence and bringing over and sort of having one platform. So what we've done is we've brought over all the goodness from Windows, the good background infrastructure from Windows. We brought that over from Windows Phone. So those of you that were phone developers are probably familiar with the concept of a background task, which is actually very analogous to a background agent. Very similar things. It's a separate hosted process where you can run a little bit of code at specific times. And of course, putting in a separate process is important because that means we don't have to carry around all the heavyweight UI components and so on that really eat up memory. So this is super important, of course, on the phone where we have lots of real sort of breadth devices that are very limited on memory. And then when we talk about background tasks, again, for those of you who are not familiar with them, background tasks respond to triggers and conditions. So the trigger is the thing that fires the background task. The condition is the thing that must be true for that task to fire. So again, analogous to background agents, you can say the periodic task from Windows Phone 8 is kind of like a background task that's time triggered every 30 minutes. So that's just sort of to set the nomenclature. Very equivalent concepts. And then one thing is a little bit different from Windows that we've also brought over here in Windows Phone 8.1 is that applications must explicitly request access to run in the background. So there's an API you have to call to tell our background infrastructure that as an application, I want to be able to run in the background. I'll talk more about that later and some of the implications that might have on your code. So triggers. I'm going to talk about here just some basic triggers first, and then I'm going to talk about a bunch of more advanced triggers later. So these are the basic triggers. We brought these over from Windows. They're all available on Windows Phone. First of all, the system trigger, which has a bunch of trigger types underneath it. User present, user away are things that will fire when the device becomes active or inactive. Session connected, that's strictly speaking when the user logs in. On the phone, there's only one user, so that will be when the phone boots up, more or less. Time zone change, fairly self-explanatory. Network state change, internet available are things that fire when either the network becomes available or not available, or if you change from, say, cell radio to Wi-Fi, for instance. Those triggers will fire. Service incomplete is interesting. When you upgrade your app, say from version 1 to version 2, you can register for this trigger associated with a background task. That background task will fire after your update is done. So that's useful if you've changed the schema of some of your data or you want to do that during an update to make sure everything works well. Time trigger, again, fairly straightforward. Set an interval for how far in the future you want the trigger to fire, what the interval is, and then that will fire more or less after that amount of time. Again, things are fuzzed on the phone, so you're not guaranteed an exact time when that will fire, but within about 30 minutes, or it's free. Maintenance trigger. This is, again, analogous to the resource-intensive task a little bit. When the phone's plugged in and charging, this task will fire. You can do a little bit more complex syncing jobs and stuff like that when this trigger fires. So I'm going to do a quick demo here of background tasks for Windows Store applications on the phone. This may be familiar to some of you if you've built Windows applications before. If you haven't, this will be new, but the concept should be familiar. So I have here a very simple hello world kind of application. Really, it's just a template with all I've done is I've added a couple methods here that I've stubbed out, and then I've added a couple buttons in my XAML for requesting background access and then registering my background task. So I'll fill in this code in a second. The first thing I want to do is I want to actually add my background task. So here I'm going to create a new Windows runtime component. I'm going to call it background tasks, very original name. And I'm going to rename this class here to, we're going to use time zone. So we're going to call this time zone task. And then the only thing you need to do is have your class implement the iBackground task interface. Here, just have Visual Studio resolve that for me. And then I will implement it. And there's not much actually to this interface. It's just simply this run method that will get called when your trigger is activated. And then so I had a little snippet there. I'm not going to go into this in too much detail. There's other sessions on how to do toasts and tiles. But here I'm just creating a toast notification with a template. And here it's going to pop up hello from background. So that's really it. This is a very simple task. Not too much going on, but it will show us a little bit how this works. And so next I'm going to go into my manifest. And first of all, because I'm showing a toast, I'm going to set this here, say that I'm toast capable. But the important piece is that I go into my declarations tab here. I create a new background task. I'm going to add this here. I'm going to say I'm using system event. And I'm going to specify my entry point. In this case, I'm going to use my time zone task. And then, so that's all I have to do now in the manifest. On Windows, if you're familiar with Windows, you had to also set a tile icon for the start screen. You don't have to do that on Windows Phone. The two concepts are completely separate on Windows Phone, being on the lock screen versus running in the background. So now the last thing I need to do is actually request background access and then register my task. So here I've stubbed out this method, and I'm just going to have my snippets go here. So here's the Magic API where you request access to run in the background, request access async. This tells our background infrastructure that, hey, this application wants to run in the background. On Windows, typically what happened at this point is there would be some UI that would come up, and the user would explicitly allow or decline your application to run in the background. On Windows Phone, that will happen implicitly. So there won't be any UI. If there's room on the device for your application, if the device is in a resource state where you can run stuff in the background, you will get a result back from here that says you've been allowed. Otherwise, you'll get denied. So if it's important that your application has these tasks, if they're not sort of opportunistic in our optimization for your application, at that point, if you get denied, you should do something here and tell the user that some functionality in your application may not work, and they should go explicitly enable your application to run in the background. So that's registering your background. Requesting access. The next thing we need to do, again, if you're familiar with this, the pattern is pretty much the same. I check if I have any tasks registered, and if they're registered, I skip the next step. Optionally, another thing you could do is you could remove them all at this point and then just re-register them. So in this case here, I'm just checking they've already been registered. And then so now is the interesting part here for actually registering. I create a background task builder. This is the mechanism you use to actually associate the task with the trigger at runtime. Creating a new trigger here, a system trigger of type time zone change. And the second parameter there is called one shot. And what that means is, do I want the trigger to fire every time this thing happens, or just the first time it happens? So in this case, I want it to fire every time, so I'll set that to false. And then here I've created a new condition to say only fire this trigger when the internet is available. I'm actually going to remove this because I don't trust the Wi-Fi network in here. I'm going to remove it down here where I actually add it to the builder. I give it a name, which I'd specified earlier. Then I give it the entry point. Actually, one thing I forgot to do earlier, and that's why that's showing up in red, is I have to make sure that I'm referencing my background project from my foreground. So now that I've done that, this will resolve nicely here. And that's just a handy way to not have any spelling mistakes, is to use that. You can type it in as a string. This just takes a string. You could do that too if you want. So here I set the trigger to the builder, and then I actually register it. So I'll set just a breakpoint here quickly, just to show you that. And then the last thing I want to do is set up my completion handlers. So there's a couple completion handlers here. I'm only going to do the completed handler, which will fire when your task is completed and your application is in the foreground. You could also have one. There's also a progress one. So there's a variable you can set that will sort of maintain progress, so you can communicate between your foreground and background application as well. So now I will run this. Hopefully I didn't make any mistakes. Looks good. And then what you'll see again, a very simple application with these two buttons. The first thing I do is request access. So you can see here my result always may use real-time connectivity. There's a couple things in this enum. You may or may not get real-time connectivity. It doesn't really matter. The thing you want to make sure of is if you get denied, you tell the user if that's important to you. So that's that. We will now register the task as well. I didn't set a breakpoint down there, but it's fairly straightforward what's going on. And then if I actually want to fire this for real, I can then go into settings here, and I will change the time zone to date and time. Where do you guys want to go? Hawaii? Hawaii. Let's give that a try. And there you see my toast fired. Fantastic, right? So I mean that's interesting. You know, it's sort of new if you've been working from Windows Phone that we now have explicit events that can have your task fired. So that's great. One other thing that's interesting that I just want to show you briefly. You know, I did both of these in C#. The code you implement the background task in doesn't have to be the same. So you can implement your background task in C++ or in JavaScript. And I'll show you it's a little bit different in JavaScript. So I'm gonna show you that here. So I have actually in this project I have a JavaScript folder here. So this is what it looks like in JavaScript. Again, I'm doing the same thing. I'm showing a toast, this time hello from JavaScript. Yeah, so I mean, that's the JavaScript code, fairly straightforward there. And then the interesting piece a little bit is in the manifest. I'm going to create a new background task entry here. Again, system event, but this time instead of entry point, I'm going to set the start page. And I'm going to give it background task.js. And then over here, I'm going to create a new registration method here. So this is the same thing as I did before with the registration, where I'm going to register a JavaScript task in this case. And I'll just stick this up here so that it runs when that runs. But again, you know, exactly the same code. Again, I'm specifying the JavaScript file in this case as an entry point instead of the entry point in the assembly. And then the interesting thing here, so I'll just register this again. But what we can do in this case is, oh, it didn't work, is we can now go back to the settings and we can fire, oh, I know what I did wrong. So anyways, that's going to show both of them. So I'm just going to skip that. But anyways, it's the same thing. You'll get a toast from JavaScript in that case. So back to the slides. So that's great. But if you've been developing for Windows Store applications, that's not new. You guys have done that before. What's new? So first of all, the important thing, I'm sure you've been to some of the sessions where they mentioned Silverlight 8.1. We've added all of this background infrastructure functionality to Silverlight 8.1. So you can protect your investment in your existing Silverlight applications. If you upgrade them to Silverlight 8.1, you can then use all of this new background task functionality. So you can replace your background agents with background tasks. You can get these new triggers and conditions and all this new functionality in your existing Silverlight applications. And in fact, as soon as you upgrade to Silverlight 8.1, we'll actually host your background agents on top of the modern background infrastructure. And what this means is that it should work pretty much. It will work pretty much exactly the same. But we'll be using sort of the modern resource management and the modern activation under the covers. Your APIs will still look the same. You don't have to change any of your code for the background agent. But it is being hosted in sort of the modern application model in that case. What that does mean, though, is if you do want to mix and match background tasks and background agents, you shouldn't do them in the same project. You should pick to go immediately over to background tasks or stay on background agents. Because when they're both hosted on the same infrastructure, what will happen is one is expecting the Silverlight CLR and the other one is expecting the WinRT CLR. And if those both get activated at the same time, the universe explodes. If you're doing C++, that's not a problem. You can have C++ background tasks and C# background agents, and that'll work fine together. But C# agents and tasks is a dangerous game. So the next thing I want to talk about is some of the new triggers. Bluetooth and sensors, this one's really cool. So we now have triggers associated with Bluetooth LE, Bluetooth RF COM, as well as most of the sensors on the device. So what this means is that you can access those sensors, and as long as you're sort of in that session with Bluetooth or with the sensors, you can talk to those sensors while you're not in the foreground. These are based on the existing WinRT APIs on Windows. So if you're familiar with sort of using those in the foreground on Windows, the Bluetooth APIs and the sensors APIs, those have all been brought over to Windows Phone. You can use those APIs here. We've just added a bunch of new triggers so you can use them in the background. So for Bluetooth, we've added the GAT characteristic notification trigger, a bit of a mouthful, but that's, if you've used Bluetooth LE, you know what the GAT is. This is the service that that tells you when things have changed, sort of raises an event on the device, and this gets translated into a trigger, and then we activate a task at that point. You can then process the event. And if any of you were in Andrew Klinik's session, he had a demo with a Bluetooth heart rate monitor that was using these triggers, actually using the device change trigger, which is the same sort of thing, where you can have sort of a long-running task that you explicitly launch, and then you can talk to your sensor or to your Bluetooth device there. And in that case, he was using a Bluetooth LE device, but then associated with the device change trigger, so there was a long-running task, and he was just receiving events from that device. Sorry, that was the device update trigger. I got them mixed up. Device change trigger happens when your device disconnects or reconnects. So if you have one of those like key fobs or something, and then it disconnects, you can get a trigger, you can raise an alarm. And I think the Bluetooth guys are going to show a demo of that in their session, a pretty cool demo with that. And the RF comm connection trigger is another long-running task, again associated in this case with the Bluetooth, Bluetooth 3.0 RF comm connection. So that's Bluetooth. Geofencing, another new one. Now, if you've been building apps for Windows Phone for Windows 8.1, geofencing was available there. It's now new on Windows Phone 8.1. If you're not familiar with what a geofence is, this is where you can pick a longitude and latitude location and specify a radius around it, and then whenever your device crosses that fence, an event will be raised. And of course, same APIs that you're using in the foreground, you can now use in the background. So here's just a quick little code snippet. The pattern's the same. You create your geofence. In this case, I've got a location and a radius. I use background task builder. I associate my location trigger with the geofence, and then I associate that trigger with the background task. This allows you to do something like you can create a geofence around a house or work or something, so you can have task fire when you get to work, do something, or task fire when you get home, say welcome home, something like that. Again, there's another session on location later on. Push triggers. So push triggers are interesting. This allows you to associate a WNS channel with your background task. So you set up a push channel, a WNS channel in your app, and then associate that with your background task. And any raw notifications that come over your channel and are associated with the background task will then fire your background task. So this is pretty useful, actually, if you want to get some data from your cloud service via push notifications and then process it and then do something with it. So obviously, real-time communication or IM instant messaging applications that would be useful for. But you can also use it, for instance, it's great if you have like a news application or something and you want to send a notification that pops a toast the user has tapped on. You can then kind of get that notification early, get data from your web service, process it, and then when the user taps on the toast, launches the app, you've already got the data downloaded. So you don't have this case of like launching the app, you have the wrong thing for a few seconds, and then the right thing shows up. So you can sort of use that to really optimize your experience for the user as well. So those are pretty cool. I have a demo for this. Let's see here. This is going to be a pretty cool demo if it works. It's a high-risk demo. What it is, I mentioned that there's a session going on right now about WNS, and they're talking a lot more about WNS and about this trigger as well, specifically some of the things you can do with this trigger. And what I actually did is I snuck onto their laptop a little bit earlier, and I grabbed the URI for their push channel. So what I'm going to do, this is actually their code for their demo, and I'm going to send them a push notification right now and see if we can mess up their session a little bit. So what's going on here? I have their URI. This is actually from their demo. I've stolen their code shamelessly, and I've gotten their URI, and I can send them a little message here. And what's going on is when I send this, Thomas over there, trust me, he's a friend of mine for now, he's given his little demo. We'll see if this comes over. This may or may not work. We'll see. Let's see if we can, make them do something. It says it's going through. Maybe we can hear them. Anyway, so what's going on here? If this is actually working, this is actually firing a background task on his device. Toast is popping up. There, yeah, thanks. Yeah. Let's see if they can hear us. Everyone clap really loudly. Let's see. Yeah. He's going to get me back for that one. All right, Thomas, thanks. So yeah, that was push notification trigger, super useful trigger. One other thing that we're adding, again, if you're from Windows Phone, you're familiar with one of the most common things we see developers do on Windows Phone is actually render their tile in their background agent. So, in your periodic, on your 30-minute interval, you actually, new up some XAML, and then render that to a bitmap, and then associate your tile with that bitmap. And if you've done Windows 8 development, you know that that's not available from background tasks. The XAML tree is not there. We've added it. We've created a new background task type called the XAML rendering background task. That is basically a background task plus the XAML visual tree. This allows you to get that exact scenario where you want to render that tile in the background. Yeah, you can use render target bitmap, which again, if you're familiar with Windows Phone, that's analogous to the writable bitmap. It's the new version of that, converged version of that you can use. So I have a quick little demo of this. This is another one that's pretty quick. And the interesting thing here is more that I want to show you that again, the process is exactly the same. I'm just going to run this here. Quickly again, create your request to run in the background, register your trigger, associate it with a background task here, actually. So I've actually ruined this demo by having that on there. So let's just try this again. And we'll uninstall this guy. So the interesting thing that I'm doing in this demo that I'm going to show you is that I've written the background task in C++. And one of the reasons you might want to do that for your background task is that you can actually save a lot of memory by doing that. So here I'm just registering it, same old thing. Again, this is a C++ time zone trigger. So that's registered. And then I'm going to go pin this tile. Make it a wide tile here. Great. And then we'll do the same thing. We'll set the time zone here. Time. We'll go back to where we started from. And then you'll see that what's happening here is I'm getting this onRun method called. And the C++ is going to be a little bit hard to follow here, so I'll just walk you through the big parts. Is, the first thing the important thing actually that I'm doing at the beginning, which is interesting, is I'm grabbing this deferral. And what the deferral does is normally when you sort of fall off the end of your run method, we'll terminate the background task. But if you have code that's running on a different thread, the deferral allows you to tell us, hey, don't kill the background task yet. I'm still doing some work. So I'm grabbing the deferral, and then at the end, when I've done all this asynchronous work, I call complete on the deferral. So that's an interesting thing, definitely useful for things like this, where you want to put stuff on different threads. So here I generate the tile. In this case, what I'm doing, I'm reading in an XML file that's got a bunch of XAML in it that I've created. Again, there's some sessions that talk about how this actually works. Then here we go. Now I render the XAML tree to a bitmap here using render target bitmap. And then finally, I write that buffer to a file. So here I'm generating an image from it. Again, don't worry, C++ is a little bit verbose, but I wanted to show it in C++. And then here I actually then associate it with the tile. And then we should see our tile change when we go back here. So now it's changed, but I ruined the surprise for you guys by showing it early. But anyways, that's how you update a tile. And again, the reason why I did it in C++ is because you can save a few megabytes. If you have multiple tiles to you definitely will be able to update tiles from C# if you want to do that. But if you say you might have multiple tiles you want to update, or you have more processing you want to do, you can definitely save a bit of memory by moving to C++. You don't have to load the CLR in that case. So there's probably 3 or 4 megabytes you can save, which doesn't sound like a lot, but it actually is a lot, especially on some of our 512 meg devices. So that's kind of a lot of the background task stuff. One other thing I wanted to touch on before I move on is background transfer. So again, if you come from Windows Phone, you're probably familiar with the background transfer service. If you're coming from Windows, this isn't new to you, but we've added the windows.networking.backgroundtransfer namespace to Windows Phone. And this is great. If you upgrade your app to Silverlight 8.1, or if you're building a Windows YAML application on the phone, you should definitely use this. It has some major advantages over the background transfer service. There's no file size restriction. You can upload as big as you want. We support multi-part MIME, so you can chunk your data, and if it fails, you can start back where you left off. We have more verbs in FTP. Also really cool in-stream progress access. So while your data is downloading, you can start accessing it. You can start showing video and so on. And then, of course, I think the most important reason, other than the actual ability to run in the background with it to use this, is that it's data sense and battery saver aware. So you don't have to worry about what state the device is in terms of battery usage, how much battery is left, or if the user of the device is on like a pay per kilobyte plan or pay per meg plan or that kind of thing. We'll take care of that if you set the property for us to do the right thing. We will then, for instance, if the user's like over their data cap for the month, they've used all their data, we won't download data over cell. We'll wait till they're on Wi-Fi before we do that. So I'll just show a quick demo on that as well. Here we go. I think I still have the debugger running, don't I? Here we go. So I'll show this, and what this is going to do, again, a fairly simple demo. And what's going on here is we create a download request. So when this runs, we'll start the download. This creates a download request, new background downloader here. Where's my step through? There we go. I've associated with a group. This is important if you want your downloads to be grouped together. And then this is the interesting piece here I sort of mentioned, is we can set the cost policy. So we can set this to always unrestricted, which essentially only over a Wi-Fi is kind of what that means. Always forces it to happen. I've set it to always here for this demo, just in case, again, I don't trust Wi-Fi that much. And then default is kind of do the right thing. So you should try and use default whenever you can, unless unrestricted works for you. That's even better. But default is will take into account battery sense and data sense. And then sort of quickly here, I'm just creating more toast notifications and tile notifications for when this is done. And then I create the download. Download helper is a UI element I've created, and you'll see this here as it downloads. So if we go over here, we can see it's starting to download. And hopefully I can get to this here. Oh, I missed it. Oh, there. So now toast is coming up. So, sorry, I didn't hit start in time. But anyways, that would happen. That would show up anywhere when your download is done. Let me just run through that again. And see if I can get it in time. We'll start another download. We'll just do a couple, and then we'll see. There we go. So that'll show up as completed there. And that's kind of a notification that you can send a tile. And you can also show a toast if the download there was an error. So I can associate the error handler with a toast. So you can give a message, and the user can tap that and then get you back into your app. I'll also show you in-stream progress, in-stream access here quickly, just by I have a larger download. There it is, right here. So I'll just switch this over. To a larger download. Do the same thing over again. And in this case, what I'm going to show is in-stream video access. So I'm going to start the download here. And again, hit that breakpoint. So this is a much larger file. And we can let it download a little bit, and then it's actually downloading to isolated storage, and then I can start reading it directly from isolated storage. In this case here, I can start playing the video, and so this video is playing while we're downloading. And now we can just sit here for a few minutes, and we can watch the keynote that you all saw this morning. All right, we won't do that. So that's background transfer. That was the good news. Now this sort of bad news. A couple things are a little bit different on Windows Phone. Not available, first of all. There's a few triggers that were on Windows that are not available on Windows Phone. Online ID connected state change doesn't really make sense. We only have one ID on the phone. Lock screen added, lock screen removed. Again, we don't associate lock screen with running in the background on the phone, so those don't really make sense. And then we also don't support the control channel trigger on the phone. So if you're using that, your application, we don't have support for that on the phone. Also, there's a few things in terms of background execution that you may be using from your Silverlight application that are not available on Windows XAML applications yet. So continuous background location, if you're doing turn-by-turn or fitness applications, runs under lock, so there was ability for Silverlight applications to continue to run even when the user locked the screen, as long as they were in the foreground. And we don't have that for Windows XAML applications. Then also VoIP agents and wallet agents. So if you're using those, you can continue on Silverlight 8.1. You can use all these great new features that we've added here for background execution. But if you're building a new Windows XAML application, those aren't available. And then finally, I kind of want to talk a little bit about battery saver and resource management. So you guys may have been familiar with battery saver a little bit from Windows Phone 8. As a concept, we've now sort of beefed it up a lot in Windows Phone 8.1. There's a new application called Battery Saver. And what it actually does is it shows you all your applications in the order of how much you've used them. So it's new in Windows Phone 8.1. It allows you to sort and manage and see which apps are executing in the background. So I can go into here and I can actually decide which apps I want to run in the background and so on. And this is kind of the infrastructure that controls how many apps can run in the background. So instead of having them associated with the lock screen like they are on Windows, they're basically, you can think of when you do that request access, you're asking Battery Saver if they can run in the background. And so if you're familiar again with Windows Phone 8.1, we had limits on most devices of 15 things that could run in the background at any given time. We've expanded those limits. Again, on our breadth device, on the 512 megabyte devices, that limit is 20, so we've moved from 15 up to 20. And that's really just because of memory on the 512 meg devices. On higher than 512, it's 20 megabytes. But then what the user can do is they can actually override that setting, so they can go into apps explicitly and then allow them to run. So I'm just going to give you just a quick little tour here of Battery Saver, and actually it doesn't do all that much on the emulator here. But I'm going to run it. So it doesn't actually show the bars that I showed there on the emulator because it doesn't really get good data in an emulated environment of how much you're using. So here's just sorted them alphabetically. Normally they'd be sorted by usage. But then I can go into an app that I like or dislike. That one didn't work. Let's try, well, I have to try one that I've actually run, I guess. There we go. And then again, there'd be some bars here that aren't showing up on the emulator. But in this case, I can say, I don't want this app to run in the background because it's using too much battery or whatever. Or I can say, even when I'm in Battery Saver, and if you're not familiar with Battery Saver, this is a mechanism that the user can set, and they can set it to come on automatically, for instance, when their battery's low. But this is a mechanism that sort of turns off all background usage, turns off push notifications, everything on the device when it's in Battery Saver mode. But I can say, I think this app is important. I want it to run even when I'm on Battery Saver. So you might use this for like your IM applications or Skype or something if you still want to get calls in that case. And then, so the other thing is, if you do get denied from that request access async API, this will be set to off. And the user can go in, as I mentioned before, and they can explicitly set this to on. Then their app will run in the background no matter how many background applications are on the device. So we're really giving users control there over what runs in the background on their device. So that was Battery Saver. Sort of related to Battery Saver, just want to talk a little bit about resource constraints. you're familiar with probably, if Windows Phone also on Windows, all background tasks have CPU, memory, and network quotas. Windows uses a CPU clock mechanism to measure how long you're running in the background versus on Windows Phone, we used a wall clock mechanism, so you got that 25 seconds, whereas on Windows you get a certain number of CPU seconds. So we've moved, by moving over to the modern background infrastructure, we're now measuring things in CPU time, as well as wall clock time, so we do have a limit on how long a task can run. This will vary based on if the device is plugged in, or if the user's actively using the device. It's always at least 30 seconds, but it could be longer if the device is in a state where it can potentially allow that. Memory quota, so we had restrictive memory quotas on background agents in Windows Phone 8.1, in 8. We've added a little bit more memory in 8.1, and then we've also started scaling the amount of memory across devices. So if you do have a device with more memory, like a 1 gigabyte or 2 gigabyte device, you will get more memory for your background task. And that's something you can query at runtime to see how much memory you have available. And then as I mentioned earlier, the time trigger is fuzzed to 30 minutes on the phone. That's just an important sort of FYI. It was 15 minutes on Windows. Everything on the phone is converged to 30-minute intervals, so we've done that. Again, it's never exactly 30 minutes because we fuzz it based on other things going on the device, but that interval will be closer to 30 on the phone than to 15. And then just one final thing, call request access async. This is new if you're from Windows Phone. We implicitly do it for your Windows Silverlight 8.0 applications. So you don't need to change your 8.0 code, but again, as soon as you upgrade to 8.1, you need to explicitly ask the system to run in the background. So you need to call background execution manager.request access async. That's what I showed in those samples there. Always make sure you do that so that you get your full quota. Otherwise, you'll get a reduced quota, which is not fun for anyone. So I'm just going to wrap up here. The key things, background processing is converged with Windows. We brought over all that goodness. Tons of new triggers, tons of new things you can do in the background. Really, just a bunch of stuff. You asked for this, we gave it to you. I'm really happy that we've been able to really expand what you can do in the background on the phone. While still having a really great experience where the user doesn't suddenly have the battery dead in their pocket, which is what we really want to avoid. We want to sort of keep the user in control and have faith that their device their phone will always work for them. So always make sure that you're aware, especially on the phone. Memory can be a restricting factor, but definitely there's tons of new stuff you can do on the phone. And really, that's it. So from here, I just kind of want to point to a couple more sessions. This is kind of an overview session. If you really want to get depth on some of these things that I talked about here, again, there's a notification platform session that's going on right now. Check that out on Channel 9 for sure, Thomas and Jorge. Building geo-aware apps. This is geofencing. Christina and Mike's session tomorrow. Definitely worth checking out if you're interested in location stuff. Live tile enhancements, Matt's session. So that sample I kind of whizzed through about generating your tile in the background, Matt's going to give you a ton of information on that if that's what you're interested in. Definitely worth going to. Bluetooth. The Bluetooth stuff is awesome. They've got a great demo on with a key fob, and they can show you how all that works in the background as well. So take a look at that session. That's on Friday. And then finally, if you want more details on some of the resource management stuff, both in the background and the foreground that I mentioned, Andrew Whitechapel's session on Friday is a great one to go to as well. And there's another session I don't have on here. There's a Silverlight 8.1 session tomorrow where they do talk about background tasks a little bit in the context of Silverlight 8.1. So that's another one worth checking out. So finally, feedback is important. Scan this QR code. You guys know how this works. You'll be entered into a fabulous prize drawing. I'm not sure what it is, but I'm sure it's fabulous. I'm sure it'll be more fabulous the better you rate me. I'm pretty sure that's the way it works. So keep that in mind. And while you guys are scanning that, I'll take some questions. If you want to just come up, there's a couple mics here. I just want to come up to the mics. And the first few folks that answer questions, I've got speakers for you. You've probably seen these in the other sessions. They're fabulous. You guys don't want to hear that. All right. Question 1 over here.
Is there a limit to how often one of the triggers can occur? So say, if you change your time zone, every 10 seconds just as a test, is it going to limit you to how often it can run?
Yeah, so it's the same mechanism that Windows uses to regulate those things. So if you're familiar with that, it'll be the same. But basically, we count the amount of CPU time that your application is using in the background over a course of a 30-minute window. And if you pass that amount of time, for triggers like time zone, we will queue them up. And they won't fire until your pool of resources refills at the end of that 30-minute interval. So that's for things like time zone. For things that are critical, though, like a push notification, which might have an instant message associated with it, in that case, those things don't apply. So they still have a finite amount of time that they can run once they're activated, but you can activate as many as you want in that 30-minute window.
So what about something like a geofence trigger? So if I hit one fence and then plot another one, I'm not using much CPU time when I trigger, so I'm not using much. Am I going to get limited on just the number of times?
Yeah. So geofences in particular are quota enabled. So if you do hit too many fences, those will get queued up. Typically, if you're just kind of logging the fence, you should be able to get a ton of fences in that 30-minute interval. The amount of CPU time we give you is actually quite a bit. So you should be able to get a lot done. But definitely, that's something worth talking to. I think Christina has some information on exactly how many fences can probably be hit in most cases during that sort of interval.
Oh, thank you.
Cool. Come on up. I got a speaker for you. Next question. Over here. Let's go back and forth. Let's try to.
Okay. Hey, so you can now explicitly request access for background stuff. Does that mean that you have 15 apps running in the background on your phone thing, disable some to have this in the background? Is that gone?
It's mostly gone. You'll still see it once you hit it with a Silverlight 8.0 application, and that's just for backwards compatibility. But yeah, it's completely gone for Silverlight 8.1 and completely gone for Windows YAML applications.
Sweet.
So big round of applause
Yay.
for that. That's great. I think it's a much better UX too. It's really cool. Come up and you can get your speaker over here.
Yeah, so you talked about on the like the download transfer manager or whatever, the
Background transfer. Yep.
Yeah. You said you could hook into the stream. What all can you do with the stream at that point?
Well, it's just a file stream at that point, so you can pull data from it and process it however you want.
So could you like encrypt it or whatever, do whatever you want?
You can start decrypting it, yeah. If depending on how it's formatted, as long as you don't need the entire file to do that, then absolutely, yeah.
Okay.
Yep. Over here.
So you showed that you're using a JavaScript or a C++ background agent in a .NET app.
Yeah.
So is there maybe any way I can use a Silverlight background task so I can actually do location tracking real time?
So you mean like the continuous location tracking?
Yeah, it's a complete showstopper. We can't do this for us.
Yeah, no, that's a feature that's not available. The background location tracking is not available to Windows YAML applications. And that's actually a different facility. The Silverlight one actually keeps the entire application running while it's not in the foreground. So it doesn't separate it into a separate process. So it is kind of a different architecture in that case.
So there's not even a workaround in an enterprise scenario where it doesn't have to go to the store?
Sorry? Say that again?
There's not even a workaround in enterprise scenarios where we don't have to go through the official store?
No, there isn't. No. I mean, it's the actual facility that's not there. It's just code that's not there. It's not in that case, it's not a restriction that we're placing on store versus non-store apps. It's actually not there.
Please add that.
Okay. I'm working on it. Want a speaker? Over here.
Yeah, can we now queue a background download from a background task?
Thanks. Yes.
Great, thank you.
Is that possible? Write my own background task and triggers to deal with my device drive.
Device driver. You're building phones?
Yep.
Yes, you can. You come talk to me. There's a way to get that done. Yeah.
Okay, thank you.
Yeah. You want a speaker? If you're making phones, you don't need a speaker, but here.
Thank you very much.
Is there a limit on the number of background tasks you can have?
For a particular app, for your app to have background? No, there's no limit. I mean, there's a limit, but it's a lot. You won't hit it.
Is it better to have multiple very simple background tasks over one complex background task? Performance.
From a performance perspective, it's not going to make a big difference. I mean, we just have a table in the implementation. The difference between having a couple things in there versus 100 is not making a big difference on performance. Do whatever's best for your code, whatever whatever architects it better.
Cool.
Yep. Sorry, you got an open box. I wanted to take a look. That's the last one.
Is it possible to have to keep a socket, a TCP connection open to somewhere on the network and wake up on incoming data?
So that's the control channel trigger.
Yeah.
So if you were building Windows applications, you could use the control channel trigger. You can associate a TCP socket with it, and your background task will be woken up whenever there's data on it. So that's not available on Windows Phone, unfortunately. Something we're looking at in the future, but is currently not available on Windows Phone. Sorry. A lot of those scenarios you can go through. Often you can go through the WNS push notification network, sort of build that, and then activate your task that way. But yes, you can't do that on Windows Phone.
Is there a limit in the memory quotas for Silverlight versus native store apps?
They're more or less the same. We tweak them a little bit just based on the size of the assemblies we have to load. So you can think of effectively a background agent for Silverlight versus a background task in C# will have the same amount of free memory available. But their total amount of memory available is a little bit different because the CLR uses a little bit different memory in those cases. If you go to C++, though, we don't load the CLR at all, so you get a bunch back. But you have to write in C++, which takes longer. And it's more error-prone and messy. And sorry, I shouldn't say that. I love C++. I really do, for some things.
Thank you.
Go ahead.
Is there any way to reduce some of the constraints if the job needs to be done it's very urgent? Means can the constraints be overridden if it's not run after some time after the trigger?
Sorry, like what's this? What are you thinking of there in terms of a scenario?
Maybe we have given a constraint, but after the trigger, if the constraint is not met, means the task won't run, right?
Right.
But if it needs to be run after maybe 10 minutes after the constraint, after the trigger, even if it is not run after 10 minutes after the trigger, can the constraint be removed?
So I'm not sure I understand. So you're talking about if you've used up your resource quota, and then a trigger fires.
Yeah.
What happens then?
Yeah.
Yeah. So it depends a little bit on the trigger, but most of the triggers will latch until your pool refills, and then they'll fire then. In that case, triggers that fire immediately will fire immediately. Ones that don't fire immediately, or that that have to use this quota, they will have to wait until the pool is refilled.
Thanks.
Over here.
Yeah. So my question is, if I have a background task and I check on that option of saving the battery on, is there a way when the phone battery is like more than 50%, start that background task again? Like resume the task?
No. So I think what you're trying to say is, when battery saver turns on or when battery saver turns off again, you want the tasks to fire. No, they won't fire. The triggers in some cases will latch while battery saver is on. It just depends if the device is active or not, and in which case it will fire. But typically they won't. So there isn't a mechanism for that. What you can do is create maybe a time trigger. For like every 30 minutes, so at least then you'll get kind of close. At that point, you can check the battery level. You can check if battery saver is on from that task.
So let's say if I am downloading something, I am downloading a database and it's on a network and it's taking time to download, and I'm hitting a battery point where it cannot go on for too long. So my tasks, like it pauses for a while, and then when battery is to a 50% or more, then the task resumes and I start downloading the data again.
Yeah, so when battery saver comes on, we actually do terminate the tasks. We don't keep them suspended on the phone at least. So what you'd have to do, I think, in that case, is create either another background task or have that task already there on some other condition, like network becoming available if that's what's kind of triggering in the first place, or just a time trigger that can then check if the battery, or just implicitly once the time trigger fires, that means battery saver is no longer on, kind of by definition. So you can then restart your work from that point.
So whatever that was downloaded will be terminated or discarded, or?
Yes, that's right. Yeah. Unless you use background transfer, the
sure.
APIs. Yeah.
Thanks.
Go ahead. Oh, sorry, over here.
Real quick, the queues that are triggered, are they maintained order maintained?
Yes, although there's cases where some of the
Right, you
triggers...
can jump the queue.
Well, they'll jump the queue. Yeah.
Okay.
Yeah. Over here.
Can a background task register a background task?
Yes.
Okay, so can conceivably, getting back to continuous location monitoring, could you register a location trigger with a very small geofence, have that trigger, and then when that triggers, register another location trigger with a very small geofence?
You probably could do that. You'll probably run out of CPU quota before you want,
Okay.
so you'll have this kind of, you'll run and then you'll stop, and then you'll run and then you'll stop. And you're not guaranteed to run. You can try it. I'm not sure.
Okay.
Yeah. Sounds cool.
Yeah, thanks.
Over here.
Yes, this question is Windows Store's applications background task. And do you have any ideas to remote debug or debug to register the background task when the main application is not exist? For example, session connect or the trigger when application ends.
Yeah, so a couple of things. I mean, one is you can actually explicitly fire the the trigger, and I'll just show you that here from Visual Studio. If you go up here, so this guy's actually actively debugging right now, and I didn't give a name for this guy. Oh, this is actually something else. There's other background tasks associated with here, and I didn't give him a name, but normally you would see the name up here. This just happens to be the one I'm running. And if you clicked on this here, it would say like time zone triggered task, if that's what I'd called it. And that will actually explicitly fire the task at that point with the debugger attached. So that's how you can actually debug the task that way. You can also associate it with a different trigger if you want. But then if you want to actually see when something like session connected fires, I don't think there's a way to attach the debugger to a task sort of as the device comes up. I don't think that's possible. But certainly you can debug the task explicitly by using that mechanism in Visual Studio. I'll just put this back up in case you guys want to give me some more fabulous reviews. Over here.
I work on a turn-by-turn navigation app that follows the Direct3D XAML model. So we rely on being able to run in the background. If we want to migrate, we would lose it if we went into Windows XAML, so we'd have to stick with Silverlight 8.1.
Yeah, I would recommend for now sticking with Silverlight 8.1. You should be able to get all the features you need in Silverlight 8.1. If there's something in particular that's not working, come talk to me. But that's just one that didn't make it in Windows Phone 8.1.
What about pure C++?
So it's kind of like, there was a question earlier there, is that mechanism, in the case of turn by turn, we're actually keeping the entire application running, so it's not separated into a separate background task. So it's actually like a whole facility and concept that we don't have in Windows XAML applications. So it doesn't really matter what language it's in. We actually don't have the facility to keep an application running when it's not in the foreground on the phone for Windows XAML applications.
So that's Windows XAML, but what if it's pure Direct3D C++? Is that okay still?
Direct3D, I don't believe it's available for Direct3D. DirectX applications, no.
Okay.
I think even in Windows Phone 8 that wasn't available, if I remember correctly. Okay. Now what you can do if you do want to do a D3D application is there's a D3D control that you can add to Silverlight, and then you can render your D3D into there.
That's what we do now.
Yeah, and the performance is pretty good for that. Yeah. I don't think there's a session after this, so if there's any more questions, we can keep going. Don't want to tire these folks out. But that's it? Cool. Thanks, everyone. Oh, well, one last question.
May I? Is there a way to build a reliable custom alarms app?
No, not really. You like on Windows? So
Yeah.
you can create alarms on Windows Phone, but they will be the system alarms. And that's definitely available, and those are reliable alarms. They use the system UX, but you can't sort of have a customizable alarm in that on Windows Phone.
Okay. Thank you.
Yep.